Okay, I think you can start it.
Okay.
Yeah.
So today we're going to solve this linked list question called maximum twin sum of a linked list. So in a linked list of size n, or n is even, the ith node of the linked list is a twin of the n minus 1 minus ith node. So this is a pretty bad description, but basically what I think they mean is that you want to calculate, the biggest of this and then the ends. So 5 plus 1 is 6, 4 plus 2 is 6. So the result is going to be 6.
Mm-hmm.
And the key to note here that really tripped me up is that the size is always even. So if the size is always even, you know that you can just start there. There's going to be a left mid and a right mid, and you can start there and expand outwards.
Mm-hmm.
And that's the key size. So, for example, if n equals 4, node 0 is the twin of node 3.
Mm-hmm.
0 and 3 are twins, and 1 and 2 are twins. So, okay, so since we're given a linked list, first thing I like to do is just put them all into an array. Cool, so now we have the linked list as an array, right? Pretty simple, right? Now we can manipulate what we need to manipulate. So, okay, since we know this is even, we need to find the mid, which is going to be the midpoint of our list, which is, so since we have a length of 4, the mid is going to be here, not here, right? Because we're rounding down, right?
Yeah.
So, okay. As I said, now because we have an even, we can actually do this nice trick where we have a left right and we have a right right, and we put the left right at mid minus 1 and right at mid. Sorry, mid plus 1, because mid is going to be the left one. And okay, cool. Now we can just sort of compute what our maximum is going to be. So while we're still in bounds, so we're going to expand from the middle outwards. So bigger than or equal to 0, that means left is not too far to the left of the array, and right is not too far to the right of the array. Then we can actually compute the max of left and right, because right now we're adding 4 and 2 is 6, and we're going to take the maximum of that. And as I said, we're going to keep expanding outwards. So left minus because we're going to the left, and right plus because we're going to the right.
Okay.
And then so next we're going to add, left is going to be 5 and right is going to be 1. And so it's going to be 6, and we're going to compute that, which is the same thing. And then we're going to expand, and they're both going to be out of bounds. And at that point, we can actually just append the sums and then compare them because we want the largest sum. So is this bigger or is this bigger? And we're going to append each of them. And then at the end, we just return the max of the sums. And let's see. Okay. So there is no results because results a list. So, okay.
Okay.
So made a mistake here. It might be, is it minus 1 and mid? It might be some rounding down, rounding up. Okay, yep, that's what it was because, okay. Yep, that's what it was because you see this right here. Mid is supposed to be 1. Or sorry, no. Sorry, mid is 2. Because length of 4 divided by 2 is 2, right?
Yeah.
And then we want the left to be on index 1, so left is 2 minus 1 is 1, and then right is 2. And then that's the correct math. So
yeah.
There you go.
Yeah, I think yes.
So again, this solution would not work if the input list was not even. The fact that we have an even is great, and so we're just expanding from the middle outwards.
Okay.
Or if the length was odd, it would be a little different. I mean, there would just be one middle node, like left, right, and right, right
Mhm.
would just be like this if the length was odd. Right?
Mhm.
So
I think it's
so
good.
cool.
Cool. Yeah, I think it's good. Your explanation is good, and okay, so you just go through the given node, right, and assign to the arrayness.
Mhm.
Yeah, and then you just and then the second while rule you just
This is just
expand.
binary search almost.
Okay. It's not binary search. I think it's two pointer.
Two pointer, but we're expanding from the middle outwards, whatever you want to call it. It's like a palindrome pattern.
Okay, but okay.